Hello, this is Jordi from Dapcom, and in this video I will show you our FARSHY visualization program, which is implemented in Java, and therefore it's portable. It can be run in Linux, Mac, or Windows. In the case of Windows, we provide an installer and an executable and everything so that you don't need to worry. And for Linux and Mac, you just need to download the jar file and run that as any other Java program. So you can proceed just downloading FARSHY for Windows, installing that just following the usual installation procedure. It's very standard. You will need a license for that, but you can test it for a few times before the evaluation license expires. But here in this video, I will show you what you can do, especially for maritime watercolumn data. FARSHY can also be used to visualize raw satellite imagery, hyperspectral imagery. Here comes the name. But in this case, we will examine this specific watercolumn file, kindly provided by Fulpro. This is the example of the original file. We have already loaded that with open KMall watercolumn, and then you choose which one you want to open. It is pretty quick. I will show you the performance afterwards. But here it is just to show you the standard view that you can change with preferences, changing the look and feel, the interpolation algorithm to show the several pixels. You can set bilinear or bicubic for a slightly better view here when interpolating the algorithms to your screen, interpolating the pixels, sorry, to your screen. But let's leave that to just nearest neighbor, which is good enough, and it will give a faster experience. Then the color scheme, this one is called Turbo. Then some mixed colors that I will show you later, which you can also change the color scheme. Some image comparison options. I will not enter into those details now. The page size, to keep some things in memory, it's just for performance. With 100 megabytes, it should be enough. And then the spectral representations. These ones are for the hyperspectral raw imagery of satellites. And for watercolumn images, this is what matters to you, which is for the stacking view, the stacked view of the watercolumn images, which tells you, where you tell the program how many swaths, how many pinks you want to stack to get some of the views. Let's leave it like this. And then in the case of the watercolumn, you can also check the GPS coordinates lookup, which allows you to show the exact coordinates here as provided by the KMall file. I forgot to mention that it just works with the new format. With the old watercolumn format, the .wcd files, it doesn't support them yet. We are considering to include them. But anyway, here I was talking about this GPS, and then for the SIS program, for Kongsberg SIS, you can integrate that with the program so that you just set the IP address for the SIS socket system and the port for SIS. It should just run as is. And it will allow you something that I will explain later. Let's start with the standard view. It is just the original image here. It shows the depth axis and the across track in meters. And then with this controller, you can just move through the several swaths one by one. You can, of course, use the mouse wheel here or here, just using the mouse wheel here to move through the several swaths. You can see that it's quite quick to do. You can also just go quickly through these. You can see how fast it goes through the full file. It is a 1 gigabyte file in this case. So you see the how lightweight the program is. Now let's move to the stacked view, which shows a smoother view of the watercolumn as in other programs, just stacking 8 swaths to show one of these frames, so to speak. And then when you move in this specific case, you see some features here But when you move further, you see some gas seeps in this case, moving forward and backward, forward and backward. So you can see these are the swaths that are being seen here. You can also see the sea bottom, highlighting that with the board and the starboard colors as usual, as in other programs. And yeah, it's just the way it works. You see some features of the file here, the coordinates here as well. Then what I mentioned before, in that port configuration, you can, for example, go to the place where you have the interesting features and send these GPS coordinates to SIS with whatever label that you want to do here, sending that, and then yep, that's it. It will be called object one. And on SIS, Kongsberg SIS, you should, in the adequate view, you should see one user object, sorry, appearing in the screen of SIS. Okay. You may send different coordinates. This one may be called object 2, for example. And when you have sent several ones, you can also export even without SIS. You can do all these without SIS. Just doing as if you would be exporting sending the coordinates to SIS. But it will allow you generating this kind of internal table and then exporting that to some CSV file with all this information, with the timestamp, with the latitude and longitude, and the depth for this specific case. Okay, so it's also useful in case you want to examine that later. Another feature of FARSHY, in the case of watercolumn files, is showing the along track view here that you can maximize a little bit. And again, when you move backward and forward through the line that you have stored in this file, you can see perhaps here some features, which are these gas seeps that we have seen. You may have noticed that the fan shape is constant. It's not adapting to the depth, to the actual depth and width of the multi-beam sonar, of the several pinks, the angle and everything, because it's the other way around. We are adapting here, indicating just here the depth of the seabed as indicated by the KMall and KMWCD file, and also the across track width in meters, which also just updates the value, not the aspect. It's another kind of another way of viewing the data, the fans. Okay. Now I wanted to show you how you can also use this program to quickly view how FAPEC, the professional data compressor, affects the water column data depending on the lossy level that you have applied when compressing the data. This is the original file. Let's just leave it here. And now we will remind you how you can compress. For example, this would be the file. You can compress and go to mode-specific options, go to KMall, and then select, for example, here we start from no losses at all. This is lossless. And then for the water column amplitude samples, you can progressively increase the losses. You can set, for example, level 4, nothing else. Save that here to the command line interface defaults, as I explained in another video, and click on compress. When you recover this compressed file, or even with FARSHY, you can directly open the FAPEC archives. We will do that with another screen of FARSHY. You can have two FARSHYs open at the same time if you wish. And in this one, you will see the speed when loading this 1 GB file. We go here, we select this level 4 lossy compression of the amplitude samples and click on open. It's first indexing the file, then starts loading the file, and just in a few seconds in this old computer with a slow disk, it should be much faster in your computers, you see that quite quickly we already see a first view of this image. The program is still loading the file. Typically, you should see a status. Sorry, it is the wrong. Yeah, here. That was the original window, the lossless window. You see here that it's still loading the file, so it hasn't finished loading the complete file, but at least it gives you the chance to see the first swaths while it's still being loaded. You can even switch to the stacked view while it's still loading. It tells you the estimate of the seconds remaining. And now I'm going to switch between the original file, lossless file, and the lossy file. Let me try to adjust this a little bit. We are almost there. Here we are going also to right click and no, of course you can still not show the along track until the file has been completely loaded, just for you to be aware. Okay, let's just leave the program finish the loading. We are almost there, 2 seconds, and the loading is complete. Now we can also show the along track. Okay, let's just try to adapt it a little bit. It's quite equivalent now. Okay, and you can see that I'm now changing between the original lossless file and the lossy compressed file. You can't barely notice any data loss at all. Even with the raw original view, swath by swath, which has a slightly worse appearance, you can barely notice any loss at all. It is because typically the capability of the KMall files go beyond what the human eye can see when plotting the data. And FAPEC performs quite some smart lossy compression in this case, okay? So let's switch to something more aggressive. Let's load another file, which is this lossy 8 that I before compressed and decompressed, doing this, going to FAPEC, going to mode specific options, KMall, and setting this to 8. This is the 8th level out of 16. You can go as high as 16. And this would be for the amplitude samples of the watercolumn, okay? Then we would go to compress, decompress if you wish, and so on. And once you load that, sorry, let me just close this, close WinFAPEC, and go again to open KMall file, open the lossy 8 level file. Let's leave it working a little bit, and it will soon, quite soon, show the very first swaths of this new lossy compressed file. Wait a little bit more, and it's just a mistake depending on certain Windows platforms. It switches to the previous window. Let's switch again to this lossy 8 file, and once again we are in the original view of the lossless file, and in the lossy file we are in the original view, and you can see that still you can't barely notice anything here, whereas we have increased a lot the compression ratio. And especially when we switch to stacked view, switch here also to stacked view, this is the lossless original file, this is the lossy file with quite high loss level. And you can see that we don't barely notice anything at all. So generally speaking, it is quite safe to apply some loss level. You should evaluate that very carefully for your purpose, but at least at a human view aspect, it's very difficult to notice any losses when you compare this quite high loss compression of a watercolumn file against the lossless original file. Even when we go to those gas sips that we saw before. We are here, and this is the lossy file where you see basically the same thing compared to the lossless file, okay? Now let's go back to the first swath. And here we can just, it finished the loading. It is the lossy file, again, going back here. And just for the along track representation, we can compare the two, and you can see, again, barely any difference between the two. Let's now switch to the case of smart lossy compression. It is another option of FAPEC. This is Smart Level 8. We click on Open, and it corresponds, while it's loading, it corresponds to this compression option. Let's go back to the standard, the basic lossy level of MWC, the water column amplitude, to 0, and just activate this lossy, a smart lossy compression of the water column. We click on accept, click here, and it will apply this lossy compression. When we compare the row swaths, now we do see some difference, some clear difference. This is the row view. This is the row original view of the lossless image, the lossless file. And when we compare, now we clearly see some differences. And as you can imagine, it basically attempts at removing those samples that look like they do not have any signal, because they have a too faint signal compared to the overall histogram of all the samples of the water column, okay? But when we switch to the stacked representation, you can compare the original lossless with this smart lossy view. We still see clearly a lot of differences, but when moving, you see that some features that we saw here, that you may have not noticed before in the original file here, they can still be seen here. So it looks like this compression mode is still useful for certain use cases. Even more, when we reach the gas sip swaths, you can see that we still can see them very, very clearly. So in some sense, this smart lossy compression allows you to remove the noise, remove the useless samples in the overall fan, in the overall swaths of the water column, whereas you are still seeing the overall view of the along track image, of the fan view image, and most important, of the several features that you can see in a water column file. I think that's all I wanted to show you. There are different features of the program, such as, for example, clicking here in the right click, you can plot this pixel here, which will appear here as a kind of spectral representation, in the sense that this axis is the several swaths that you have in your file, and even you can click this one, adding this this pixel, which will show throughout all the swaths, also this one, for example, also this one, for example, and you can see here the several dots that you have added to the file, and when you move, they are kept here, and depending on the use case, it may be useful for you to show how the signal changes at a given fixed location of this triangular shape of this fan view, again, when you move through the several swaths of your file, okay? Last thing that is worth mentioning and very interesting, when you have one file loaded, a part of the row view, the original view and the stacked view, you have the mixed color view, which will automatically show in different colors the swaths where a given pixel of the fan view takes the highest value throughout the full file. And as you can see in this specific case, just with this single image, we very clearly see the gas sips that were just in one specific swath or pink of the file. So it is a very useful feature of this visualization program, specifically for maritime watercolumn data. And that's all. I hope that you find it useful. For any question, just drop us an email. Thank you.